Okay, so we're on the My Maths exercise Trigonometry Missing Angles, and we're going to have a look at question 1. So I've drawn question 1 on my board here, and we've got an angle called x that we're trying to find out. So we're going to try and label all of the other sides as they apply in relation to this angle x. So in relation to the angle x, the side 2 is opposite it. So I'm going to label that op for opposite. And then the 4, well, the 4 is the longest side. We know it's the longest side because it's across from the 90-degree angle. So irrespective of where x is, the longest side is always the hypotenuse. So we've got opposite and hypotenuse, and then we need to remind ourselves which of the 3 trig ratios involves opposite and hypotenuse, and in fact that is sine. So just to remind ourselves, sine is opposite over hypotenuse. So in this case, sine of x degrees, whatever it is, equals opposite over hypotenuse, which is 2 over 4. 2 over 4, which as it happens is a half, or 0.5. So, well, why not write that as 0.5 now? So we want to know what x is. So x isn't the sine of 0.5, but x is the angle that when you do the sine of it gives you the answer 0.5. So that's subtly but importantly different. So x is kind of the inverse sine, or the unsine or anti-sine of 0.5. To give it its proper mathematical name, the arc sine. So it's the kind of reverse of the sine function, the thing that undoes sine if you want to get rid of a sine both sides. So on the calculator, here's the calculator. I need to make sure my calculator is in degrees mode actually, which I notice it isn't. So let me try and find the mode button to, there we go, degrees. So I want that in degrees mode because I'm working with an angle that's in degrees. So on this particular calculator, I've got my sine button, but I want the arc sine, and you can't really see it on the screen very well, but you've got the sine button, and then above it it's got sine and then a little -1, which is denoting the inverse sine function. So that sine with a little -1 is another way of writing arc sine, but actually I prefer arc sine because that little -1 is a bit confusing with something to the power of -1, which, like 5 to the power of -1, which means something different altogether. So I don't actually like that notation with the -1 to denote the inverse function. But anyway, so x is we can call it the inverse sine, but I like to call it the arc sine of 0.5. So I have to press the green button first on my calculator, and then sine, and then can we see that on the screen? It says like sine with a little -1, meaning inverse sine or arc sine, and then 0.5, close the bracket, equals 30 degrees as it happens. So that's a nice round one. X equals 30 degrees. So I'm just going to put that on the iMath screen. So here's the iMath screen, and I'll type in 30 degrees, and then the next one is an angle x up there, 6 over there, and 13. So I will draw that on my board. So as if by magic, that triangle has appeared. So it was 6 centimeters, 13 centimeters. I mean, the units don't really matter because this could be meters or miles or anything, and the sides would still be the same in relation to one another, so it wouldn't actually change what the angle is. But in any case, let's label this. So we've got the angle x, and the 6 is opposite the x, so that's the opposite. Then we've got two other sides. The long one here is the hypotenuse, and we know it's the hypotenuse because it's opposite the biggest angle, opposite the 90. So that leaves the 13 as the adjacent. So we've got a trigonometry problem that involves the opposite and the adjacent. So just to remind ourselves, tan is the trig ratio that involves opposite and adjacent. Tan equals opposite over adjacent. So in this particular case, the tan of x, the angle we're trying to find out, is equal to opposite over adjacent, 6 over 13. So that doesn't mean that x is the tan of 6 over 13. It means that x is the angle that when we do the tan of it, we get the answer 6 over 13. So we need to kind of do the reverse tan of 6 over 13. So the inverse tan, it's often called when you're doing it on the calculator, but I prefer to use the proper name arctan. Arctan 6 over 13. So I get my calculator and I press the green button to get the inverse tan or arctan, and then it does that horrible -1 notation that I don't like. And then it started some brackets for me, so I can just do 6 divided by 13, close the brackets, and press for the answer. 24.775. Let's call that 24.821 decimal place. I'll just double check on the iMaths exercise that give your answers to the nearest whole number, it says. Okay, so 25 then, that's going to be to the nearest whole number, approximately equal to 25 degrees. So there we go, 25 degrees to the nearest whole number. Okay, now we've got a triangle with a right angle there, an x up the top, and a 3 and a 2. So I will just draw that one. So there's that one. Now we've got the right angle here, so the 3 must be the hypotenuse because it's the longest side. We know it's the longest side because it's across from the biggest angle. The angle that we're trying to find out is x here, and the 2 here is adjacent to it. The adjacent side being the one that's next to the angle that we're talking about, but isn't the hypotenuse. So we've got adjacent and hypotenuse. So let's just remind ourselves of that. That's cos. Cos equals adjacent over hypotenuse. That's the trig ratio that we are going to use. So in this particular case, let's do it over here. Cos x, maybe I won't do it over there actually, because I think I've got more space over here. Cos of x equals adjacent over hypotenuse 2 over 3. So that means that x itself is the inverse cos, or I like the proper name, arc cos of 2 over 3. Just about squeeze that in there. So on my calculator, so the shift or second function button to get arc cos rather than cos, and it gives me that horrible -1 notation that I don't like. It's opened some brackets for me, so I'm just going to put 2 divided by 3, close the brackets, and equals 48.189, so that's 48 degrees approximately. So 48 is what I'm filling in on the iMaths. So let's fill in 48 and then go on to the next question here. So here's the next one. I haven't drawn any of these diagrams accurately, so they're just kind of rough triangles to show where everything is in relation to everything else, so that I get everything in the right place. So I haven't constructed this with a compass or anything. It's not necessarily accurately drawn. It's almost certainly not accurately drawn. So in any case, we've got the right angle there, so the 7.3 must be the longest side, so that's the hypotenuse. The 5.6 is next to the x, so in other words it's adjacent to the x. The adjacent is the one that's next to the angle we're talking about, but isn't the hypotenuse. So we are going to use cos again. Cos equals adjacent over hypotenuse, and in this case cos of x, the angle we're trying to find out, is equal to the adjacent 5.6 divided by the hypotenuse 7.3. So cos x equals 5.6 over 7.3. So x itself is not cos of that, but it's the inverse cos or arc cos of that. I hope I can just about squeeze that in. So 5.6 over 7.3, just about. Yep, so x is the arc cos or inverse cos of 5.6 over 7.3. So onto the calculator. So the shift button to get arc cos rather than cos, and it gives me that horrible -1 notation I don't like. It's opened some brackets for me. 5.6 divided by 7.3, close the brackets again, and equals 39.9, equals 39.9, so approximately 40 degrees to the nearest degree. Okay, the next one had an x down here, so the 3.6 is opposite the x, it's the opposite. The 4.9 is across from the 90-degree angle, so the 4.9 is the longest side, it's the hypotenuse. So we've got opposite and hypotenuse. That's sine. Sine equals opposite over hypotenuse. Remind ourselves. So in this particular case, sine of x equals opposite over hypotenuse, 3.6 over 4.9. 3.6 over 4.9. So x itself is the arc sine or the inverse sine of 3.6 over 4.9. So out with the calculator. Shift button first and then sine to get inverse sine or arc sine. 3.6 divided by 4.9, close bracket, equals 47.28. So that's 47 degrees to the nearest degree. So I filled in 47 there, and then on to the last one, which I will draw up on the board, which I've already drawn up on the board actually. And here it is, and we've got an x. 6.9 is opposite the x, so that's the opposite. This one here that isn't labelled is the hypotenuse because it's across from the 90-degree angle. So the 7.3 is the adjacent. It's the one that's next to the right angle. Let's just move that down so it's in shot. It's not next to the right angle, the one that's next to the angle we're talking about, but isn't the hypotenuse. So to remind ourselves, it's tan, that's equal to opposite over adjacent. So in this particular case, we've got tan of x that we're trying to find out equals opposite over adjacent 6.9 over 7.3. So x itself is the arctan or inverse tan of 6.9 over 7.3. I think I need another new pen. arctan of 6.9 over 7.3. Time to get the calculator out. So second function button or shift button with the tan to get the inverse tan, and it gives me that horrible -1 notation that I don't like. It's open brackets for me. 6.9 divided by 7.3, close the brackets, equals 43.3 and a bit. So x equals 43 degrees to the nearest degree, and I'll just put that on iMaths. So that's 43 degrees I want to write there. 43. Let's click it to mark it. 12 out of 12. That's satisfying.